Hello everyone, this is Praveen Kumar, Government Lecturer, Government Bulletin currently. I am welcoming you to session 3 of Unit 6 of Mechanical Measurements. In the previous session, we have learned about basic definitions of limits, fits and tolerances, and we also had a graphical representation of all the terms related to limits, fits and tolerances. I hope everyone has understood the basic definitions of limits, fits and tolerances. In this particular session, we will be learning about fits and types of fits. That is, we will have a basic definition of what are fits, and we have different types of fits. We will learn about that, and also at the end of the session, we will also have a video which will give you more idea about types of fits. Okay, now let us have what are fits. A fit is an assembly condition between hole and shaft. Or fit is defined as a degree of tightness or looseness between two mating parts to perform definite function when they are assembled together. So that is called fits. Now we will know what are types of fits. There are three types of fits. They are clearance fit, transition fit and interference fit. And now we have what is a clearance fit. In the diagram we will see what is a clearance fit. That is, it is defined as the fit established when a positive clearance exists between the sizes of holes and the shaft. In this type of fit, the largest permitted shaft diameter is less than the smallest hole diameter, so that the shaft can rotate or slide according to the purpose of the assembly. So that is clearance fit. Now the clearance fit can be subclassified as follows. That is loose fit, running fit, slide fit or medium fit. So what is interference fit? So interference fit is defined as the fit established when a negative clearance exists between the sizes of holes and the shaft. In this type of fit, the minimum permitted diameter of the shaft is larger than the maximum allowable diameter of the shaft. That you can watch in the figure given below. And now we have the interference fit, which can be subclassified as follows. That is string fit or heavy force fit, medium force fit, third one tight fit or press fit. And now we have third type of fit, that is transition fit. In this type of fit, the diameter of the largest allowable hole is greater than the smallest shaft, but the smallest hole is smaller than the largest shaft, such that a small positive or negative clearance exists between the shaft and hole. Example, coupling rings, pivot limiting poles, etc. That you can see in the picture given below. And now the transition fit can be subclassified as follows. That is push fit, force fit or string fit. And last is ringing fit. And now we will have a video on what exactly all these fits are divided, and you will have a clear picture on how all these types of fits. So let us go through the video.
Clearance fit. In this video, we are going to see about clearance fit. The clearance fit for the boss is regarded as a shaft 30 mm hole. A hole is defined as the member which houses or fits the shaft. It may be stationary or rotating. A positive clearance exists between the hole and the shaft. It is obtained by selecting the maximum and minimum limits of the shaft and the hole. Interference fit. In this video, we are going to see about interference fit. Consider a bolts pressing machine, hub, pressure gauge, a fit between two parts in which the external dimension of one part slightly exceeds the internal dimension of the part into which it has to fit. Fastening between two parts, which is achieved by friction after the parts are pushed together rather than by any other means of fastening. The hole diameter is smaller than the bolt diameter. It is an interference fit. Transition fit. In this video, we are going to see about transition fit. Hole, shaft, hammer. For example, by hammering, insert the shaft into the hole and fix it. When the dimension of the hole and the shaft such that there exists a positive clearance when the shaft is fitted into the hole is known as transition fit.
Okay. Hope you all have understood what is clearance fit, what is transition fit, and what is interference fit. Now we will know the definition of the sub-classification of clearance fit. As we all know, clearance fit can be sub-classified as follows. That is loose fit, running fit, and slide fit or medium fit. Now we know what is a loose fit. So loose fit is used between those meeting parts when no precision is required. It provides minimum allowances and is used on loose pulleys and agriculture machineries, etc. And we know what is a running fit. For running fit, the dimension of the shaft is smaller enough to maintain a film of oil for lubrication. It is used in bearing pair, etc. And the slide fit or the medium fit. It is used when on those mating parts where great precision is required, and it provides a medium allowance and is used in tool slides, slide valve or automobile parts. So that is it about the loose fit, running fit and slide fits. So these three are the sub-classification of the clearance fit. Now we will move on to the sub-classifications of interference fit. So that is interference fit can be sub-classified into string fit or heavy force fit, medium force fit or tight fit. That is the string fit. The string fit is, it refers to the maximum negative allowance in assembly of the hole and the shaft. The hole is expanded by heating and then rapidly pulled in its position. It is used in fitting of rims, etc. And then the medium force fit. These fits have medium negative allowances and considerable pressure is required to assemble the hole and the shaft. It is used in car wheels, armatures of dynamos, etc. And the third one is tight fit or press fit. So one part can be assembled into the other with a hand hammer or by light pressure. A slight negative allowance exists between two mating parts. It gives a semi-permanent fit and it is used on a keyed pulley and shaft, rocker arm, etc. So these are the three sub-classifications of interference fit. So now we will move on to the sub-classification of transition fit. So we all know that transition fit can be sub-classified into push fit, force fit or string fit and ringing fit. So now we know what is a push fit. So push fit, it refers to zero allowance and a light pressure is required in assembling the hole and the shaft. The moving parts show least vibration with this type of fit. It is also known as a snug fit, force fit or strength fit. A force fit is used when two mating parts to be rigidly fixed so that one cannot move without the other. It either requires high pressure to force the shaft into the hole or the hole to be expanded by heating. It is used in railway wheels, etc. And the last one is ringing fit. A slight negative allowance exists between two mating parts in ringing fit. It requires pressures to force the shaft into the hole and gives a light assembly, and it is used in fixing keys, pins, etc. So these are all the different sub-classifications of clearance fit, interference fit and transition fits. So hope all of you have understood types of fits and different types of fits and you have had a clear picture with the video that is shown in the session. So we will have the further topics covered in the next session. Thank you.